Hello everyone, I am Akhil. Welcome to my poster presentation. This is my abstract enhancing hyperspectral classification through graph convolutional networks with adaptive graph construction. Now these are some of the prerequisites for this study. This is a hyperspectral image, an image which is very different from the usual 3-channel RGB image we happen to see in our daily life. It consists of a contiguous number of channels, something like a number around 100, which contains a huge amount of information. This is mineral mapping using hyperspectral images. Mineral mapping is simply to map the unique spectral profile of each pixel to its actual mineral based on the similarity measure. Now on the right side you can see a graph which contains spectral signatures of each end member. You can also see that each end member has a unique spectral signature. This is graph representation. Graphs are something which we see in our daily life but never notice. A best example of graph would be a social media connections. This is how a graph look like on the left side, and this is how the same graph can be represented on the right side, which is something called as an adjacency matrix. Adjacency matrix contains values that represent the degree of connection between two nodes. What we are trying here is to achieve the best representation of connections between nodes that this adjacency matrix can contain. This is the main idea of hyperspectral image classification. Now our main focus here is on the graph construction of the pre-processed hyperspectral image to pass it onto the GCN graph convolutional network. There are different strategies to build relationships between pixels. Now these are some of the strategies we happen to analyze in our study. Now what kind of relationships are they? The first three you happen to see are which only consider spectral relationships between pixels. The fourth one, which considers both spectral and spatial relationships between pixels. And the last two are spectral clustering of the pixels, and the pixels are connected only if they belong to the same cluster. These we evaluated with metrics like accuracy, precision, recall, F1 score, and ROC AUC score, which are necessary metrics for classification tasks and represented here on a radar map. As you can see, the nonlinear spectral spatial relationship graph construction method has achieved best metrics over the other methods. So we conclude that using this graph formulation technique could yield better results in your graph-based approaches. Thank you.